Licensing and plan requirements for electrical work are not uniform and differ based on the specific jurisdiction. To obtain accurate information tailored to your location, contacting your local building inspector's office is crucial. They can provide the definitive requirements applicable to your area. Regarding licensing, generally, electrical work that is independent of a broader building permit may not necessitate a license. However, if the electrical work is integrated into a larger project that does require a permit, then a license may become mandatory. This distinction hinges on whether the electrical installation is a standalone task or a component of a more extensive construction or renovation endeavor. When it comes to plants, their necessity usually depends on the scale of the project. Smaller projects typically do not require detailed plan submissions. On the other hand, larger and more complex projects often mandate the submission of comprehensive plans to the local building inspector's office for review and approval. These plans serve to ensure compliance with relevant codes and regulations, as well as to facilitate proper inspection and oversight of the project. To reiterate, the local building inspector's office is the most reliable source of information concerning both licensing and plan requirements within your specific area. They possess the expertise and knowledge to guide you through the applicable regulations and procedures, ensuring that your electrical work is conducted in accordance with all relevant requirements. Always verify the exact requirements with your local building inspector before commencing any electrical work, regardless of voltage level. This proactive step will help you avoid potential compliance issues and ensure the safety and legality of your installation. It is also important to understand that low voltage is a relative term. While often considered 50 volts or less alternating current or 75 volts or less direct current, the specific definition as it relates to licensing and permitting might vary locally. Some jurisdictions may have stricter requirements even for systems operating at lower voltages. In addition to licensing and permitting, adherence to the National Electrical Code, or NEC, is essential. The NEC provides comprehensive standards for safe electrical installations covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment specifications. Even for low-voltage systems, following NEC guidelines is critical to prevent electrical hazards and ensure the long-term reliability of the installation. For landscape lighting and irrigation control systems, the NEC provides specific articles and sections addressing these types of installations. These sections cover topics such as the use of approved wiring methods for underground installations, proper grounding and bonding techniques, and the selection of suitable equipment for outdoor use. Furthermore, it is vital to consider the environmental conditions in which the electrical system will operate. Outdoor installations are exposed to moisture, temperature variations, and other environmental factors that can impact the performance and longevity of electrical components. Therefore, it is essential to use equipment and materials that are specifically designed and rated for outdoor use, such as weatherproof enclosures, corrosion-resistant conductors, and UV-resistant insulation. Regarding irrigation control valves, it is crucial to ensure that they are properly wired and grounded to prevent electrical hazards. Irrigation systems often involve water, which can significantly increase the risk of electrical shock. Therefore, it is essential to follow all applicable safety precautions and to use ground fault circuit interrupters, or GFCIs, to protect against electrical faults. The NEC mandates GFCI protection for many outdoor electrical circuits, including those serving irrigation equipment. When installing low-voltage wiring for landscape lighting or irrigation control, it is important to use appropriate wiring methods that are suitable for the specific application and environment. Direct burial cables, such as underground feeder or OFF cable, are commonly used for underground installations. These cables are designed to withstand the rigors of direct burial and are resistant to moisture, corrosion, and physical damage. However, it is important to ensure that the cables are buried at the proper depth and are protected from mechanical damage. In addition to direct burial cables, conduit can also be used to protect underground wiring. Conduit provides a physical barrier that shields the wiring from damage and can also help to prevent water from entering the system. When using conduit, it is important to select a type that is suitable for underground use, such as rigid polyvinyl chloride or PVC conduit or rigid metal conduit or RMC. When making electrical connections, it is crucial to use approved connectors and termination methods. Proper connections are essential to ensure reliable electrical contact and to prevent loose connections, which can lead to overheating and electrical fires. For outdoor connections, it is important to use weatherproof connectors that are designed to prevent moisture from entering the connection. These connectors typically have rubber seals or other features that protect the connection from the elements. Grounding is another critical aspect of electrical safety. A properly grounded electrical system provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and energize the circuit in the event of a ground fault. Grounding also helps to reduce the risk of electrical shock by providing a low impedance path for current to flow. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal parts of the system. Bonding refers to the process of connecting all metal parts of the electrical system together to create a common ground. This helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. The NEC requires that all metal parts of the electrical system, including metal conduits, enclosures, and equipment frames, be bonded together. Overcurrent protection is another essential safety feature. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices automatically interrupt the flow of current when the current exceeds a predetermined level, which helps to prevent overheating and electrical fires. The NEC specifies the types and sizes of overcurrent protection devices that are required for different types of electrical circuits. It is important to select overcurrent protection devices that are properly rated for the circuit they are protecting. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the NEC and may address specific issues that are relevant to the local area. It is important to be familiar with the local electrical codes and regulations in your area and to ensure that all electrical work complies with these requirements. When performing electrical work, it is essential to follow safe work practices. Always to energize the circuit before working on it and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on electrical equipment while it is energized unless you are specifically trained and authorized to do so. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. A qualified electrician has the training, experience, and knowledge to perform electrical work safely and correctly. They can also ensure that the electrical work complies with all applicable codes and regulations. Remember that electrical work can be dangerous if not performed properly. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. By taking these precautions, you can help to ensure the safety of yourself and others. Electrical installations in damp or wet locations require special attention to prevent electrical hazards. The NEC specifies requirements for wiring methods, enclosures, and equipment that are suitable for use in these environments. For example, wiring methods such as UF cable and liquid-tight flexible metal conduit, or LFMC, are commonly used in damp or wet locations. Enclosures and equipment that are rated for outdoor use, such as weatherproof boxes and fittings, are also required. When installing electrical equipment in damp or wet locations, it is important to ensure that all connections are properly sealed to prevent moisture from entering the equipment. This can be accomplished by using weatherproof connectors, sealing compounds, and other approved methods. Ground fault circuit interrupters, or GFCIs, are particularly important in damp or wet locations. GFCIs are designed to detect ground faults and to interrupt the flow of current very quickly, which can prevent serious electrical shock. The NEC requires GFCI protection for many electrical circuits in damp or wet locations, including those serving outdoor receptacles, swimming pools, and hot tubs. Underground wiring requires special considerations to protect the wiring from damage and to prevent electrical hazards. The NEC specifies requirements for the depth of burial, the type of wiring method, and the use of protective measures such as conduit. When installing underground wiring, it is important to ensure that the wiring is buried at the proper depth to protect it from mechanical damage. The depth of burial will depend on the type of wiring method and the location of the wiring. For example, direct burial cables typically must be buried deeper than cables installed in conduit. It is also important to protect underground wiring from physical damage by using conduit or other protective measures. Conduit can provide a physical barrier that protects the wiring from damage from digging, rocks, and other objects. When installing underground wiring, it is important to follow all applicable codes and regulations. This will help to ensure that the wiring is installed safely and correctly and that it will not pose a hazard to people or property. Low-voltage lighting systems, such as those used for landscape lighting, typically operate at 12 volts alternating current. These systems use a transformer to step down the voltage from 120 volts alternating current to 12 volts alternating current. Low-voltage lighting systems offer several advantages over line voltage systems, including increased safety, reduced energy consumption, and greater flexibility in design. However, low-voltage lighting systems also require careful installation and maintenance to ensure that they operate safely and reliably. When installing low-voltage lighting systems, it is important to use the proper wiring methods and connectors. The wiring must be sized correctly to carry the required current, and the connectors must be weatherproof to prevent corrosion. It is also important to protect the transformer from the elements by installing it in a weatherproof enclosure. Regular maintenance is essential to ensure that low-voltage lighting systems operate safely and reliably. This includes checking the wiring and connections for damage, cleaning the fixtures, and replacing any burned-up bulbs. By following these guidelines, you can ensure that your low-voltage lighting system provides years of reliable service. The distance that low-voltage wiring can run is limited by voltage drop. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. The longer the wire, the greater the voltage drop. Excessive voltage drop can cause lights to dim or not work at all. To minimize voltage drop, it is important to use the correct wire size for the length of the run and the amount of current being carried. There are voltage drop calculators available online that can help you determine the appropriate wire size. The NEC provides guidelines for voltage drop in branch circuits and feeders. These guidelines are intended to ensure that electrical equipment operates properly and that the risk of electrical hazards is minimized. When designing electrical systems, it is important to consider voltage drop and to take steps to minimize it. This will help to ensure that the system operates efficiently and reliably. And lastly, always check with the local inspector.